Hello, BC. Last one of these little videos, we're going to talk about the average value of a function. And let's suppose that I was going to try to find my average velocity. And we're going to use a simple-ish example today. Let's say that my average velocity was 2t plus 4. Or my velocity function, sorry, not my average velocity. My velocity function was 2t plus 4. And we want to find the average velocity from t equals 2 to t equals 6. Okay, well, this is pretty easy, right? It's linear, right? We could simply find v of t and v of 6, and we know that the average is going to be right in between, right? So I'm going to go ahead and say that at v of 2, at t equals 2, sorry, this guy is 8, and that at t equals 6, right? This is 16. So, you know, maybe we'll get 12 out. Who knows? So let's actually go ahead and do that. Okay. So what was our formula for average of some function? So to find f average, right, for f of x from a to b, right? We use this formula, right? We say f of average equals 1 over b minus a, right? That's sort of the difference. That's the width we can think of. Width of interval. Width of interval times the integral, right, of f of x dx evaluated at a and b, okay? And that is the area under the curve between a and b. The area under the curve between a and b, right? And if we divide by the width, that sort of gives me the average height, right? Because we can think about that curve, right? It's got a width and a height, right, that we can approximate it. And if we take the area under, we divide by the width, that gives me the height, right? So that makes a lot of sense, right? If we think about width times height equals area, right? Well, this expression is area, and this is 1 over the width, 1 over w, right? So this has to be h over here. That should sort of make some sense intuitively. Okay, so let's go back to our example here, and we're going to say that v average is going to be equal to 1 over 6 minus 2, right? Because this area has width 4. Integral from 2 to 6 of 2t plus 4 dt, right? That matches exactly what we've seen thus far, right? And again, this is, if we were to think about this graphically, right? If this is my velocity, 2t plus 4 looks something like, you know, this. It's kind of steep, right? And we're trying to find the area between 2 and 6, right? So again, we could find this geometrically. I think we said already, right, that this is going to be a height of 16, this is going to be a height of 8, this is a width of 4, and our trapezoid would say 1/2 8 plus 16 times 4, right? That would be the area of my trapezoid, right, or 48, I think is what we're going to find. Okay, so let's actually evaluate this integral, right? This is, again, 1 over 4, so that's 6 minus 2. And then this thing in here, right? This is t squared plus 4t evaluated at 2 and 6. T equals 2 and 6. We'll be consistent and write that, right? And so what that is, that's a quarter times 36 plus 24 minus 4 plus 8. 4 plus 8. You can do some arithmetic here, right? That is actually 48, right? This thing over here on the side is 60, and that's 12. So this is a quarter times 48, which is in fact 12. 12 meters per second is my average velocity, which again is what we said makes sense. It's what makes sense. Okay. And let's think about one more way of thinking about this, right? We just took the integral of velocity, which we know is position, right? We don't know where we started, right? But this thing is my position displacement, right? It's my position displacement. That's the area under the curve of 48, right? And that should make some sense that if we tried to find s of 6 and s of 2, that we would also get we would get something like this, right? Because again, no matter what, if we say s of t is going to be, again, t squared plus 4t plus some constant, right? Well, that means that s of 6 is 36 plus 24 plus some constant, or 60 plus c. S of 2 is 4 plus 8 plus some c. That's 12 plus c. So if we think of s of 6 minus s of 2, right? It's going to be 60 plus c minus 12 plus c, right? Minus this quantity. That just gives me 48, right? That says the distance we traveled from t equals 2 to t equals 6 was 48. So obviously my average velocity had to be 12, right? That's sort of two ways of thinking about this shaded area up there. Okay, I hope this was helpful. And again, I'll throw up some practice problems for average value functions, because this is going to be a major theme for the foreseeable future, whether we like it or not. All right.